Good morning, dear students. In the last video, we have started our chapter 4, Structure of Atom, in which we have last discussed about the glass discharge tube. And in that, we have also discussed that, as we know, and you have learned in 8th standard also about the atom, which consists electron, proton, and neutron, where neutron and proton are in the nucleus and electrons are in the outer orbits. But now here we will start and we will learn about how the electrons, protons were discovered. Right? And in that video we have seen that when electricity was passed through the glass tube, by taking the example of different gas, the negative cathode started giving the electrical rays towards the opposite side by striking to the opposite wall of the glass tube and giving the fluorescent color. Thus, the scientists came to know that these are the rays which are coming from a cathode, that is cathode rays. These cathode rays are applied for the production of the fluorescent color. And you have seen this fluorescent color in the hoardings. Hoardings, that means the signboards which are kept as an advertisement board. Nowadays we see when we go outside at the night on the road, we see the advertising board which is colorful, which glows with the different color lights. The principle of this cathode ray is applied over here. So let us see here the colors of signboards. What are they? A bright advertising signboards of different colors at shopping malls and around a city or a town. You all have seen. These signboards consist of many discharge tubes in which neon gas or a mixture of neon gas with some other gas is filled at very low pressure. Neon is a noble gas where its both orbits first having 2 electrons and orbit second having 8 electrons. Both orbits are completely filled and neon is having total 10 electrons. So when neon gas or mixture of neon and some other gas with it, helium or halogen gas with it, is filled at low pressure, then the sign is produced. Sign, that means glowing. When very high electrical potential is applied, high electrical potential, that means the difference of electricity between two terminals, positive and negative. When high potential is applied across these tubes, glow of different colors are produced. The color of the glow depends upon the nature of the gas. When the different colors are produced, how it is produced? It is not that only one type of gas or only one type of glass tube is used and all the time the different colors are produced. For that, the glowing of the color depends on different factors. One is, it depends upon the nature of the gas which is used in the discharge tube and the color of the glass which is used in making the discharged tube. Discharge, it means the one who is relieving the charge. Example, the colors obtained when neon gas or the mixture of used are as follow, given in the table. Gas and gas mixture, what color of the glass tube is there, and observed color of the glow. If neon is used, the color of the glass discharge tube is colorless and the observed color of the glow is orange, red. When neon is used, the glass of the discharge tube is light red, observed color is deep red. When the mixture of neon, argon is again a noble gas having 18 electrons, 2, 8, 8. All three orbit and suborbits are completely filled. And mercury in the vapor form, Hg, mercury in the vapor form when filled all together. Colorless tube is taken, the glass tube is colorless, and the appearance of the color is light blue. Again, when neon, argon and mercury is filled, the glass of the tube is green and the observed color is light green. Neon, argon and mercury when again filled and the color of the glass is purple, the the glowing color observed is dark blue. Sodium vapor street lamps. Nowadays you have heard that in big cities the street lamps are of sodium vapor, that is sodium in a gaseous form is filled in it. So sodium vapor street lamps and television tubes. We see the television in different colors. In the previous days, that means years back, televisions were not colorful. They were black and white. Nowadays, with the modern technology, televisions are also having tubes which are based on the same phenomenon of electrical discharge through gases at low pressure. Right? So this is what the discharge tube is giving us, and this electrical rays which are originated or emitted from the cathode in the discharge tube are called cathode rays. When a very high electrical potential, that is nearly 10,000 volts, is applied across a gas taken in a discharge tube, applied across a gas, that means a particular gas is taken in a discharge tube, and through that gas, when the high potential is applied, then at a very low pressure, electrical potential is high, but pressure should be very, very low. Right? In the previous videos, we have discussed 10 raised to minus 5, 10 raised to minus 3, 10 raised to minus 2. So, about 10 raised to minus 5 atmospheric pressure, or you can say 0.001 torr, which is equal to 1 millimeter of mercury column, Hg, Hgenium, mercury column. These are the unit, atmosphere, torr, mm. These are the unit of measurement of atmospheric pressure. So at this low pressure and nearly 10,000 volts electrical potential, the rays are possible. So at this high electrical potential and low pressure, some radiations are emitted from the cathode. These radiations are called cathode rays. The emission of cathode rays in a discharge tube is shown in figure here on the next page. And at this stage, that means when the emission takes place, the glass wall of the discharge tube opposite to the cathode starts glowing with a faint greenish light. This is called a fluorescence color. This is due to the phenomenon called fluorescence. See here, this is the cathode, the negative potential, and this is the anode. You can see the positive potential, right? When the rays are emitted from this cathode plate, cathode electrode, they are called cathode rays. And as I told just now, that when the rays emitted from the cathode, they strikes opposite to the cathode. This is cathode and opposite to cathode is this. And then here it was seen that this wall started glowing fluorescent green light. Right? This is the anode here. And before filling the gas, the tube was completely vacuumed. That means all other air was removed from it, and then a particular gas was filled. Which type of gas? Neon, argon, or mercury vapor, right? So this type of gas, hydrogen gas, was filled. Very first when the experiments were going on, the hydrogen gas was filled and all this rays are emitted. So this fluorescence, which fluorescence? This. This fluorescence of the wall is due to the bombardment. Bombardment is from here. Bombardment of glass by the rays. This glass tube is bombarded by the rays from the cathode, and therefore these rays are called cathode rays. Right? You can see the battery and the electrical potential. But when this bombardment takes place, the electric potential is very high, but the pressure kept is very, very low. Now, what are the properties of this cathode rays? Very first is they travels in a straight line, and so only we got here the straight back here of fluorescence. Cathode rays consist of matter particles and possess energy by the virtue of their mass and velocity. These rays have some particles, and these particles are having the energy of movement because of the virtue of their mass, whatever the mass they have, and the velocity, that means how far they are able to travel or to be in the motion. Because we know what is velocity. Velocity is a motion of a particular object with respect to the direction and time, which you have learned in physics. Cathode rays consist of negatively charged particles. They consist of negatively charged particles. Cathode rays also get deflected when subjected to a magnetic field. When a magnetic field was kept around this tube, and when cathode rays passed through it, they started giving the fluctuation. And how it came to know that they carry the negative charge? That when again an electric field was applied here, the cathode rays started bending towards the positive terminal of the electric connect terminals. So, the scientists found that when rays are bending towards positive, then they must be opposite of it. Then and only then the attraction is there. And so, it is said that cathodes carry negative charge. Cathode rays heat the object on which they fall, as cathode particles possess kinetic energy. As emission takes place, cathode rays, as I told, they are particles. They will start in the motion. And when we say that an object is in a motion, they possess kinetic energy. When object is at rest, that means they are standby. Then it is having a energy, but it is a potential energy. But now when the emission of cathode rays takes place, rays travel. We know that sun rays travel from sun to the earth. How they travel? The photons, the particle of light which is there, they are traveling, and we observe it in the form of rays. So here also when cathode ray travels, they possess energy, and the energy is kinetic energy, which also you have learned in physics. Energy due to the virtue of the position and place is potential. Energy due to the virtue of the motion, it is kinetic. So see, science is interwoven. Physics, chemistry, biology, all are interwoven. You have to keep in mind everything when you are learning, at least one. You should not skip out another. Cathode rays cause green fluorescence on glass surface. Cathode rays penetrate, that means it goes deep through thin metallic sheets. When metallic sheets are kept in between the discharge tube, if here some metallic sheet is kept, then these rays are penetrating. Penetrating, that means they are going deep into that metallic sheets and produces X-rays. When the scientists were doing this experiment, Michael Faraday, J.J. Thomson, Goldstein, right? When they were doing this experiment, they gave the name that emission of rays from cathode are cathode rays. But now when they saw that cathode rays are even penetrating to the metal, then what should be the name? So they told, okay, we are not knowing, or we are not there to give some special name. Then they are X-rays. We do know that when we don't know exactly the name of someone or some place, we say it as X. in mathematics when you're finding the value in the equation. For the unknown value, you take as an x. Let this be the x, and then you are finding the value of x. So x it means which is unknown. And since that day, the rays are called X-rays, which can pass through the opaque materials such as black plastic coated paper, which we can say X-ray sheets. When there is some damage in our internal bones, doctor used to ask us to go for the X-rays, and you can now understand what are the X-rays, right? Electrical bombardment through a specific type of gas tube which penetrates on the black coated sheet, metallic sheet. Then these are X-rays. Cathode rays travel with a speed nearly equal to the light. We know the light travels very fast, and cathode rays are also traveling very next to the speed of the light. If you want to know what is the speed of the light, then light travels with the speed 3 into 10 raised to 8 meter per second. 10 raised to 8, it means there are 8 zeros behind 1, and multiply that value with the 3. That much meter in 1 second light is traveling, right? If we say 8 zeros, that means it will be ones, tens, 100, 1000, 10,000, lakh, 10 lakh, and crore. 1 crore into 3, that is 3 crore. 3 crore meter per second is the speed of the light, and very next to it is the cathode rays. So, with the help of this cathode rays, now the discovery of electron was possible. Properties of the cathode rays show that the rays consist of streams, that means together, not one or two particle, but streams together. You might have heard word about झरना, है ना? નદી ક્યાંથી આવે છે? તો ઝરણામાંથી. પહાડમાંથી ઝરણું વહે અને ઝરણું વહીને નદી બને. That ઝરણું is called stream. So, our negatively charged particles are like stream, not one or two, but in a group, in a beam of particles. So, properties of cathode rays show that the rays consist of streams of negatively charged particles having very small mass, but their mass is very small. Sir J.J. Thomson called these particles corpuscles of negative electricity. What they told? Who told? J.J. Thomson. That electricity is particle. You might be knowing RBC in our biology, WBC, red blood corpuscles, white blood corpuscles. That means corpuscles, that means very small particles. So J.J. Thomson told that if while passing electricity from negative terminal, these particles existed as a ray. So they are negatively electricity corpuscles. Later, one more scientist, D.J. Stoney, called these particles that as they are from the electricity, so he gave that electricity elect, and they are in an atom, so electrons, right? And they gave it a name that they are the electrons. So negatively charged particles in an atom are now named electrons. Let us now see the characteristics of electron. Very first thing, we know now that negatively charged particles are called electron. So we can say that electron is a negatively charged particles, and they have very small mass. The mass of an electron is about 1 upon 1840 times that of a hydrogen atom. Now we know that hydrogen atom is having mass only 1 atomic mass unit because it has only 1 proton and no neutron. Atomic mass is addition of proton plus neutron. But hydrogen atom is the only atom out of all 118 atoms which is having only 1 proton and no neutron. Its isotopes are having deuterium and tritium, but hydrogen is having only 1 proton. So its mass is 1 atomic mass. And you see electron is 1 upon 1840 times smaller, right? So you can see 1 divided by 1840. What is the calculation? So mass of the, here it is shown, 9.108 into 10 raised to minus 31 kilogram. When I say minus, that means this many zeros are before 9. So you see 0.000000 30 times when I'll say, then 9 will come. So that much small mass is the mass of electron in kilogram, and in gram it is 10 to minus 28 gram. This was also calculated by certain experiments by Mulliken, Goldstein, by oil experiment, again by passing the gas through the discharge tube. But this all you will learn in your higher classes. An electron possesses one unit, that is the negative charge, and it has been found to be the smallest negative charge. As it is having a very less mass, it is the smallest particle, so it is considered having a very smallest negative charge that any particle can carry. No other particle can carry this small charge. And the charge of an electron is minus 1.602 into 10 raised to minus 19 coulomb, capital C. Here we will write unit in form of capital C. Capital C is the unit of charge, that is coulomb. It is also the name of the scientist who has found and who has given his effort to calculate the charge by certain experiment. And so in his remembrance, the unit is called coulomb. So this is all about the negative particles, which is due to cathode rays through the discharge, and these are the properties of electron: having negatively charged, very light in weight, with weight is 9.108 into 10 to minus 31 kilogram, 9.108 into 10 to minus 28 gram. In the terms of fraction, it is 1 upon 1840 times smaller than hydrogen, and it carries charge minus 1.602 into 10 to minus 19 coulomb. Right? So this is how you can now know that how electrons existed. And now in the next video we will see about the anode rays, which will give us the idea about protons. By the time, thank you.